Hey, welcome to Learn DGlux5 series. I'm Paul Stanko, and last time we talked about charts a lot. Hopefully you're well recovered from that because we're going to talk more about charts. However, this time we're not going to go over every bell and whistle of the chart widget. We're actually going to explore building charts using components outside of chart widgets, starting from custom renders for chart bars and markers, and finishing up building completely custom chart layouts using nothing but axes from the actual chart component. So this should be interesting and helpful to you when you're dealing with some less common, actually in some cases more common, but less obvious project requirements. So stick around and we'll show you how that's done.
Well, let's go ahead and begin, and we're going to start by creating a container in which we're going to build our chart widget. It's going to be a regular group, let's work on our data source. So we're going to jump to the data flow right away, and our data source would be multi-history block because our widget would be able to take multiple data paths and create a history. So search for get the multi-history block, and I do have few boolean and enum points with histories that I'm going to use as my guinea pigs here. So to be exact, I'm talking about 2 booleans here and 1 string, basically enum with 3 possible status values. So I'm holding control here, right? So I get the path populated instead of binding, right? And of course, I'm placing a comma in between each path. I'm going to set time range to do a relative current 1 hour, so we're not dealing with too much data here because I do have them set to toggle fairly often, so you get a lot of data within an hour. And a few quick settings for data interval. I'm not going to leave it as default. I'm going to choose none because when you deal with booleans or strings or enums, remember that you cannot really roll them up. There is no roll-up functions that are available other than first or last. So we cannot skip any intervals. So we have to do none on the data interval so we get full granularity. Basically, every single entry in the history will get returned, so nothing will get skipped. So if we take a look at what we got in the end, so let's enable the auto run so it actually runs. And this is what the history looks like. So we have, of course, a timestamp and 3 columns, 1 for each variable that we're pulling. Notice that their changes don't match, so they don't happen on the same timestamp. So they get basically joined as a union, right? So the only thing we would like to change here is instead of V0, V1, V2, we want to use the actual point names. So we can read those headers later to create actual series. So where it says header here, we're going to choose name, which gives us something like this, right? Live bool 1, live bool 2, and live status 1. This is where your habit of not using space or interesting characters in naming would pay off, because you wouldn't have to then refer to these column names later as array elements. You could refer to them by name as is if you haven't used spaces or dollar signs and whatever else. Anyway, just a little side note. So we have the data source. The next thing we can build right away is legend. So basically, whatever we display, we would want to set some things about it. I'm going to use regular table here, just call it legend right away. All right, and let's figure out what we want to store about our variables, right? Value, of course, and then label. So we need to describe all possible values to be able to describe what color we want the segments to be and which value should be considered to be a gap, right? So we want to build this universal rather than relying on just simply true, false, with false being the gap. Then we would definitely want to be able to specify a color for each, and then opacity. Opacity is what going to give us the gap, right? So in our bar timeline, with zero opacity, we'll be able to specify which specific value would map to as a gap in our bar. So let's go through values. So we have true, false. So we have two booleans. So we have true and false. That describes values for both of the booleans. And then we have labels. So we can specify how we want the true, false to show up in our data tip. So let's use start, stop. Okay, notice I'm doing this slightly simpler version. I'm not doing this per variable. So technically you could have a situation where you have two booleans, but for one of the booleans, true, false means, let's say, start, stop. And for another boolean, it might mean, I don't know, like on, off or something, right? So I'm not describing that particular situation. You could, of course, do that by making this legend more complicated, adding another column where you specify the history path or point name as a differentiator, and then just have the lookup based not only on the value but also the point path, so that you can get proper label for that point specifically rather than for any point that has a value true or value false. I'm not doing that. I'm doing it slightly simpler in order to fit this whole ordeal into a single video. So hopefully you'd be able to kind of tweak it to your needs later on. Of course, this page will be available to you for download in the comments section, so you'll be able to tweak it to your needs, hopefully once you watch how this is made. All right, and for colors, I'm going to use already, well, actually, let's continue with values first of all. So I have true, false, and then I have three more values. So in my live status point, I have three possible values, which is standby, cooling, and heating. Now, it's important that I match my values exactly here, because that's what's going to be matched on to get the rest of the parameters. So I have to make sure that I type in exactly as they could show up in my point. And then label, of course, we use the same thing, but just better formatted, capitalized in this like this. So for opacity, so true, of course, be 1 opacity, false will be 0. I'm going to, again, use the simpler method using 0 to 1, so rather than 0 to 100%, so that later I don't have to convert it back, because in SVG, the opacity is specified by a value from 0 to 1, using, of course, the decimals if needed to be partially transparent. I'm going to use the same thing so that later I don't have to do an extra conversion from % back to 0, 1. And then, of course, I'm going to use 0 for standby, and then 1 and 1 for heating and cooling for my status. And then all I have left are colors. I do have a few kind of saved here in my notes so that I can just copy paste. So I'm going to use, this is basically a blue here. I'm going to use the same blue for cooling, right? And it doesn't really matter what I use for false here, because it's going to be a gap anyway. Same thing for the standby. It's going to be a gap, so I don't care about what color. And then for heating, I'm going to use, actually, that's a red, so I think I copied the wrong color, so this is blue. Yeah, so my true is red, then false is also red, but it's going to be 0 opacity, so it's going to show up as a gap. My standby, that's technically red, but again, 0 opacity, so it's going to be a gap. My cooling is blue, full opacity, so 1, and then heating is red, full opacity, 1. All right, so and that takes care of the legend, at least for this variation of my widget. So we are ready to move on to the next task. And the next task is we need to prepare a table based on which to generate a chart. So let's sidestep a little bit and add the actual chart into this. So I'm going to use components. Insert charts, just a regular chart. Gonna full size it inside my group, and I'm gonna populate it by simply dropping one of the series from my table here in it. Now I only needed to pre-generate axes like this. So my vertical axis, of course, will not be linear; it will be category. And then my horizontal axis would be date time using timestamp. Okay, there you go. So you don't have to pay attention to this particular series, the line. I'm not going to display it, but there's a little trick. So I need it for the timeline to be generated on the bottom here. And I will need it to generate the series names here on the left. Right now it generates the actual values. I will use the same axis to generate actual series, but the series itself, right, the line series, I don't need, so I'm gonna hide it. However, there are a few tricks here. If I simply hide it by unchecking the display, then the series that was generated based on it also goes away, right? My timeline is gone. That's not good, so I can't do that. Also, if I uncheck the visible, right, it looks good now. However, the zoom will not work, and I want my zoom to work. So as a matter of fact, I'm going to go to my plot area and enable zoom, horizontal zoom, and just going to choose slightly different colors there so that it's a little easier on the eyes with some opacity. Right. You see that zoom does not work. I mean, it allows you to select stuff, but it doesn't zoom in when the series is hidden. So I can't do that either, right? Because when it is visible, right, the zoom works. So what I'm going to do instead is I'm going to go to the actual color settings, and I'm going to set basically to no line color, 0 stroke, right? So it's not visible in any form, right? But the zoom still works, and that's exactly what I want. Okay, so we have a basic chart, and next I'm gonna add another group to this, which will act basically as a container for my actual bars later on, which I will add. Right, so I'm gonna add component group. Right. Now I can, of course, blow it up. And by the way, you saw the kind of data tips quickly show up because my series was there, but it was invisible. But as I was mousing over the actual data points, I was getting data tip. We'll deal with it a little bit later. So anyway, so there's my group. Right now is just as big as the chart. I need it to only be as big as the plot area. And I can do that by going to charts plot area and expanding, this little arrow here. And the chart reports out its X and Y position of the plot area. Right? And it also exports out width and height. Right? So we can use these to literally set our group to match those exactly. So X and Y. And width and height. All right, so you see that visually here, my group got sized perfectly to the area. Also, I'm going to do a few tweaks to the axes, to the timeline. I don't like when it's bunching up the timestamps like that, so I'm just going to change the labels from show all to auto. So they basically, it'll drop labels based on available space, and then we can do further styling later on. Okay, so going back here, now I need a table based on which to generate my series. What I mean by that is this. If I look at my vertical axis, it's a category axis, and it has a table feeding the axis, data provider, right here, and you specify which column in that table contains your possible values. So right now it's live bull. That's the column I dropped on the chart. So basically it scans this column, finds all possible values that are non-null, and generates basically a tick mark for each unique one. So that's how you end up with true, false. And based on which value it finds first, right, the order could be reversed, which is why it's, it's really inconvenient to use chart's own bars or line chart or area chart to show booleans, because it's really difficult to control. So anyway, so what we're going to do is we're going to use this to feed it some different information about series. So for that, I need to have a table that gives me a column that contains all possible series that I may have, right? So this is my data table. These are the 3 series I have. So I need to, from here, I need to get a table that contains these 3 entries. So what I'm going to do is first, I'm going to get columns, and right here. All right, this gives me a table with a list of columns from a table that I'm feeding it, right? So I get row timestamp and then the 3 series that I get. I think it's, you understand as I go along that this is dynamic, right? So if I drop more series in here, I'm going to get more entries here. So none of this is hard-coded, which is the idea. So we're building a widget that's supposed to be reusable. So what I need to do from this table, I need to filter out the stuff that's not a series, which is a row and a timestamp. So I'm going to use a plain filter for that. Right, and I'm literally going to say name not equals to row, right, and name not equals to timestamp. Right, which gets us like this. So this technically this already is ready to be linked to our series provider, data provider for the series. However, there's one little caveat. The way these ticks are generated, the first one, the top of the table it starts from basically 0 coordinate and going up, meaning that the lowest one will be live bull, then next will be live bull 1, and next will be status 1, right, as we go up. However, for my bar generator, which we're going to start on shortly after this, since I'm using a repeater, vertically laid out repeater, it's going to happen from top to bottom, and I want my axes to match. So before linking this to the data provider, I'm just going to invert the order here. So I'm going to use sort like this, and I'm going to sort on row, and I'm going to do number descending, which gets me this, right? Exactly the same table, but sorted basically top to bottom instead of bottom to top. So now if I bind this to my data provider, and I'm going to say that name is my column from where to get the tick marks, I get this, right? This is exactly what we're looking for. So now each of my tick marks is a series that I dropped in, and next to each one there'll be a bar with its timeline. So that's basically what I'm going for here. So I think now we're basically ready to start working on a bar itself. So let's start doing that. Okay, since I'm gonna have to repeat the bar for every series that I have here, that means I have to have a symbol. So we're going to start by creating a group, which we're going to turn into a symbol once we're done with it. So actually, let's do this now. We're going to turn this into a symbol. Let's call this SVG line. And get right in there. And first thing, let's do a little bit of styling, right? So what we're going to do is make a background alternate slightly based on whether it's odd or even number, right? So we get alternating backgrounds as we add more series. So basically, we're going to add kind of white fill with, I don't know, just a little bit of opacity, maybe not even white. So let's do gray, so even less opacity. I'm going to create a very simple logic using the index of the component itself. You can find it on advanced properties, right? So each element will have an index. So I'm doing this for the root level of this symbol, like the group that contains the rest of the symbol. And I'm going to run it through a modulo block. And don't worry that the index is 0 right now. It will be not 0 when it's being rendered. So it's a modulo of 2, which will always give me a remainder of either 0 or 1. So I'm going to use the if block. Right? Yes, I'm going to say if it's 0, then my opacity would be 10%, otherwise 5. So this will give me 5% output, which I'm going to bind, of course, to the opacity. So I'm going to bring this up and bind here. All right, so again, so when I save the symbol, here it gives me this barely semi-transparent thing. So now if we try to stick it in the repeater, right, we should get an alternating background. So let's go ahead and try this before we build anything else. For us to try this, of course, so this is the group that's going to contain our bars that we dropped in here, if you recall, and we made it align with the content plot area of the chart. So let's name this before we do anything else. So we'll call it bars. And this is going to be vertical layout and repeater, of course. The symbol we'll be repeating will be the SVG line, the one we just finished. Finished creating. Of course, we haven't finished the functionality of it. And the data provider, well, since we already have a table based on which to generate the tick marks, and it's basically the same table to generate the lines, right? So the only thing is this time I don't want it to be resorted, right? Because the repeater, the way I have it set, because it's vertical layout, flex start alignment, it's going to generate items from top going down, right? So I don't need it to be sorted the other way around. So I'm going to use this filter output, right? So basically before the sort block. So I'm going to bind that to the data on the repeater, right? And so you saw what just happened, right? So it generated 3 elements, 1, 2, 3. Now they all share space, of course, but they become flex shrink 1, so that they all get squished equally within the space of the parent container. That's why we ended up having the equal size bars there, so they match up the grid quite nicely. As a matter of fact, I'm going to go to plot area and I'm going to reduce the prominence of grid lines to something much dimmer, maybe just 20%, like this. Okay, so now each of those is an instance of our symbol. As a matter of fact, we can delete it from here and just continue working over here. So I'm going to double click into one and let's start working on that. So first, we need to create some properties that we're going to be passing into the symbol. So I'm going to modify edit properties and let's start. So what do we need? Well, we definitely need series name. So let's do this series name. Okay. What else do we need? Well, we need to know the overall data timeline, right? So chart is going to basically show some chunk of it. We need to know what the chunk is so we can map data matching that chunk of time. So that means we need what? Start timestamp and end timestamp. Except here, we don't really need it in the form of ISO date. We need just the numeric value of it, basically the epoch time. So start, yes, that's why I'm creating a number type property. So start timestamp and timestamp. Then we need the whole data set passed in here. And because why? Well, because we're going to be building a timeline based on that. So table data. So let's just call it data in. And lastly, we need to know the legend because we're going to be creating segments and coloring them based on that legend. So again, table data, call it legend, and that should do it. So let's go ahead and save. And let's link it up so we can continue working with properties already having their values. So I'm going to open the data table that drives the repeater, go to my renderer, and one thing it can bind right away is name, of course, then the timestamp. So where would I get that? Well, very conveniently, the charts plot area, sorry, not plot area, plot area, I think, let's see. No, not plot area, the H-axis, the datetime axis. Reports that out for you, right? So kind of towards the bottom there, there's a computed minimum and computed maximum, right? So these are epoch times that the axis reports out, which includes zooming, right? So if I zoom, and by the way, to do that, I first need to make sure this bars container is mouse transparent because so that chart can receive my mouse. So when I zoom, right, you notice that the axis reports out the computed min and max for the timestamp, right? It corresponds to the zoom as you zoom in out. So that's perfectly exactly what we need. So we're going to bind these to the renderer, right? So minimum would be the start, maximum would be the end, right? Next, we need to supply the data in. So basically our actual history table from which to draw the original data. And lastly, the legend. And that should do for now. I think that gives us everything we need to build our bars. Later on, we may decide that something else may be needed for some styling properties and purposes. We can always add those bells and whistles later on. So let's get back into one of the renderers here. Let's use the status one since it's going to have the most variance, right? It has 3 possible values, not 2 here. So let's start the build out. So for now, if you recall, we only have a logic that gives it the background. And then also we have properties that already have values that we can use. So now let's do something with them. First, of course, we need the very base of this whole endeavor, which is the SVG repeater. So we're going to insert charts, raw SVG repeater, and I'm going to just make it equal to size to our whole bar for now. But I'm actually going to control sizing a little bit later. So why SVG repeater, right? So technically you could create a symbol that's a single segment and then I guess, just use a regular repeater to create that with some sizing and so on. The reason that's not going to work for you very well is because you can control just how many segments would need to be generated because, if your history toggles a lot and you're looking at a fairly large chunk of time, that means you potentially can have thousands and thousands of segments, right, of something going on, off, on, off, on, off. Repeater will basically crash your browser eventually, right? Even if it's a simple symbol that you're repeating, which is just a segment of the bar, you're going to be creating so many of them that it will eventually overwhelm your client's resources and either hang the browser or crash it or just make it very unresponsive. And I know many of you have tried to do this, probably run into this issue. So SVG repeater will be very difficult to overwhelm it. All right. First of all, it's using native functionality of the browser to generate stuff. So using way less resources. Also, it doesn't generate individual components. it generates a shape, right? Which is very different from a full-fledged components with all the properties, that you would typically deal with in DGlux. So you can get away with virtually any amount of segments, complexity of the bar, with almost no toll on the performance of your dashboard. So that's why we're using SVG repeater. The first item that we'll need is, well, we need to know the actual size of the SVG repeater, right? Or a group that contains SVG repeater, since SVG repeater is just made to match that size. So we need to know that size because we're going to have to figure out a way to scale the timestamp to actual pixels. So to even be able to get the size, we need to use resize event, right? So you can't really do it in a repeater itself. You can only do it with a group, right? Which is the repeater's parent here, or SVG repeater's parent. So I'm going to go to advanced, search for a resize event, or just search for a resize, and there's a property here, resize event enabled. I'm going to set that to true. And in my data flow, I'm just going to drag out resize event block, and that by itself immediately gives us width and height of the container that contains SVG repeater, and by extension that's also the size of my SVG repeater, because its SVG repeater itself is simply 100% by 100%, so it'll always match its parent. So that should give us enough to scale, convert time to pixels and back, basically, which is the first thing that we need to be able to draw anything with SVG here. So that's done. So next I'm going to go to SVG repeater's data flow, and well, let's first basically narrow down the data. Right now we have all the series in here. Let's pull out only the timestamp and the one we're dealing with here in this particular instance, which is live status. But it's whatever comes into this property, of course. So I'm going to use select columns block, right? So data in would be the source, right? And the columns I'm selecting would be, I'm going to concat that, of course. The timestamp will be a given, right? Comma, and then whatever series name that gets pushed into this my property. So timestamp and live status in this case, right? So that gives me a table that only has the column with the series that I care about. So next, what I can do is I can basically group. I can group the thing to get rid of all these null values, right? Because there are timestamps that correspond to values in other series, which I don't really care about. So I can do it two ways. I can do it by grouping, or I can simply do it by filtering. The reason I'm going to do it by grouping is because in the same process, I'm also going to rename. I'm going to rename the column from this column to generic one. So from then on, I no longer would need to keep referring to this property to tell it which column we're dealing with. So of course, timestamp. So we're going to go from here to the input, and sorry, my bad. Let's backtrack a bit. I'm not going to use a group by. I'm going to use column mapping. Let's do that first. So let's use column mapping. Right, that's going to go here. Timestamp remains a timestamp. Right, and this and this live status becomes value. So value becomes live status. So we get something like this at the end, right? So timestamp and value. And from now on, I won't have to bind to this anymore, at least in this series of transformations. So now I can use a regular filter. The reason I'm not going to use the group by is because it's much more resource intensive compared to the filter. So why use extra resources if we don't need to? So this we're going to filter out basically all the values were values null. So value equals to equals to null. Sorry, I need all the values that are not null. So it gives us something like this, right? So it's a much cleaner table to deal with, and this is why I replaced the actual column series name with a value, because now when I write these filter expressions and various other things, I can just hard code the word value in there rather than always having to concatenate them using the name of the series as the variable. Just makes it a little bit less messy and use less blocks. And I'm going to introduce, actually go back here real quick and change something real quick. So I'm going to introduce a new column called TS, because what I want to retain is not timestamp, but rather epoch time version of that timestamp. So I'm going to equals to, and then basically first I'm going to check if timestamp is null, because if it's null, I'm going to get a RTE when I try to parse the date of null. So I'm going to check that. So if it's not null, then I'm going to use date parse of timestamp, right? Otherwise, I'm just going to use 0. And so that gets us something like this. Right? So at the end, I get something like this, basically. All right. So again, it's a cleaner table to deal with. So next, well, I need to process this in some way to generate SVG code for each of the segments of my line, right? And the easiest way to do this, now, of course, you could write a script block that would do that. But for the purpose of demonstrating this for everyone, not just folks who are good at scripting, I'm actually just going to build it with blocks using a data flow repeater to generate each row. It might be slightly less efficient, but as you're going to see, it's going to work almost lightning fast anyway. So I don't think that's going to really matter. Also, keep in mind, for the most part, when you deal with kind of enum and Boolean histories, you typically deal with change of value type histories, not intervaled histories. So the amount of data you get is usually a lot less than, let's say, numeric one. But again, even without that, using data flow repeater is maybe slightly slower than using a script block, because in the end, it all becomes script, right? The slowest things in your dashboard are always visual, right? When you have to generate a lot of visual elements with visual properties, that's always going to slow you down a lot more than all the data stuff you do in the data flow. Just keep that in mind. So, I'll need to create a symbol. I'll need to create a symbol that that creates SVG code for me. So let's get working on that. So what I'm going to do is I'm just going to drag out like just a block, just a number block, and convert this to a symbol right away. And I'm going to call this SVG, what's it, segment, and get into edit the symbol right away. So let's figure out first what we need to pass into this block. So let's work on blocks properties, right? So it definitely needs to know start and end timestamps, right, to define its boundaries. So it's going to be, again, numeric. maybe it won't need it. I don't know. We'll figure it out. But I'm going to pass them in and then see if I can do without them or not. Next, you would need to know overall lines width and lines height, right? So width and height of the line that's available for you to draw on, right? So it knows its canvas. Again, it's going to be numeric. This is why we use that resize event block to get those values. So we'll call it line width and line height. All right, then a legend would need to be passed in. Right, it's a table. Then the data, of course. Table data, and the reason you would want data to be passed in is because technically you would get access to that row anyway on which this instance will be generated. But you need the rest of the data because you need to know next row's timestamp to know when your current block ends, right? Because you have a start of the current value. You also need to know the end of the current value, right? To understand how wide this block that you're going to draw needs to be. So you need access to the next row of data as well. And this is, you can pick it out of the overall data set. That's why I'm passing this in here. So then you would need to probably output some things, right? Because remember, whatever your symbol outputs in data flow repeater, in the repeater's output table, that becomes a column. And we need the column to drive SVG repeater, and we need columns of things. So first of all, it's going to have to output SVG code that we're going to use in our repeater. So we're going to use a text area, and we'll just call it SVG code. Right? I'm going to make this a read-only right away because my symbol will be outputting that out. It's going to be outputting a value and also a label. So value and also how I chose to call that value in my legend table, right? Remember, like when we said true would be start and then false would be stop. So I'm going to be outputting both the actual true, for example, and the word stop. So I can use them in my SVG repeater. Then I would need to know start and end of that bar segment that I'm calculating here. So I'm going to go in here, use numeric ones. Again, I may not use all of them later, but I'll just output them anyway. So that's bar start, let's use lowercase start TS, and bar end TS. So these are timestamps for start and end of the bar segment. And then I don't want my bar to be as wide, as tall as that whole area that's available to it, right? I want it to be somewhere in the middle and probably have a maximum size above which it will not grow because it just becomes pretty unpleasant when it becomes too tall. So I'm going to calculate the bar height in here in this symbol and output that. So let's do this. Code calculate bar h. Of course, all of these guys are read-only. So why am I specifically checking them to be read-only? Well, two reasons. First of all, so that somebody has to use this symbol who may not know right away what things do. So he doesn't have to guess whether he needs to bind something in them or not. When I make them read-only, they become unbindable when you try to bind them from outside the symbol, first of all. Second of all, if they're read-only, then the priority of symbol populating this value would take over versus this value being populated from the outside, like when you try to write to it with a state block, right? The fact that it's read-only, unfortunately, will not prevent you from using a state block to write to it. But symbol will have a priority to populate it compared to things outside of the symbol. So just a few advantages, but for the most part, I just wanted to not show up as bindable, so that it's just a good practice, right? It should be a habit. Even though I think when we're in a format of a repeater where we don't see those properties on the symbol block, we see them just in the sub properties of a repeater block. I'm not even sure this will prevent you from binding to them, but still, it's just a habit, and I use it. Okay, so that's that. So let's go ahead and save this and stick it into repeater right away, and then we'll continue developing that inside the repeater. So this is the repeater. So the symbol is going to be this SVG segment. The table, of course, is going to be this table, right? And let's bind what we can. So let's mouse and click outside, click back in, so the properties get rendered in the repeater block. So you see here, I think you can still bind to them even though they're read-only because they're a subset of a repeater instead of individual block. But here, right, you wouldn't be able to bind to them. Anyway, let's populate these. So line width and line height, remember that's that block over here, right? So that's our size event data. So let's grab our offset width and height, go back to the repeater and bind that. So line width will be this, line height will be this, right? Start stop TS, I think that can come directly from my symbol properties here, right? These are properties of, just close some of this stuff, properties of this visual symbol that I'm editing, right? That's one line item here. So legend, again, it's going to come directly from this visual symbol properties. So legend goes in here. So data is going to be another binding from the table that drives the repeater, right? Like this. SVG, and these of course are outputs, so I don't care. So delete this from here. We're going to continue editing this inside the repeater. So what I was talking about, see all these properties that we've created, right? If we look at repeater output, right, they all show up as columns in the repeater output, right? And the ones that we've created to be outputs here, right, they're not populated yet, but they will be, right? And we can use this output table to drive our SVG repeater. Because if you recall, SVG repeater needs a table and SVG code to generate stuff. So table is this, the code will be this column. So we'll get to it in just a second. So let's go back into the repeater. Close this table first. Close this and go back into the repeater, edit instance 1, instance 0, I mean, because why not? So if we look at the properties, right, so we get a property sheet here with kind of everything nicely already filled in. We just need to build the actual logic. And the first thing that we need to do, we need to have is a map to table block, right, which will give us the row of table row that we're dealing with here, right? So timestamp and the value. And while we're here, we also need to go next row's value, because again, we need to know when the segment ends, right? So we need timestamp over the next row to act as a final edge of this block. So what I'm going to do to grab that next row, right, again, this is where this data table comes into play. I just need to figure out which row I need to call. And the row that I need to grab will be, let's see, do we have, I think this row does give us the actual row number that carries over. Let me check real quick. So let's, instead of editing symbol, instance 0, let's edit instance, let's say 10. All right, so here, if we look at this, yeah, see, we get the original row number together in our map to table. So we just need to up this by 1. So we're going to use this, add 1, and use select rows block. Right. Close it. So let's open the properties right away. So we're going to use this data table that we passed in, and we're going to use this index 11, and that's going to be our next row, right? So now we have this row, which is this, and we have a next row. So this is our start timestamp. This is our end timestamp, right? So we have both timestamps now. That means we can actually bind them now to bar start TS and bar end TS. And then the further I go, I think the less chances I think we'll actually need those. But why not? Our table is going to supply them, and you can do more stuff with them later on if you choose to. So, okay. So what else do we need? Now we can start. Now we can start working on the actual SVG code and see what we need to do there. So I'm going to use replace block. It's basically just about any code, dynamic code is going to start with that. And I Googled for basic SVG code for a rectangle, because that's what our bar segment is, right? It's just a rectangle. And it looks something like this, right? Like this. So basically you have kind of specifying width and height of your overall playing field. And then you specify rectangle X and Y. This is where rectangle starts. Then width and height. This is basically how long and how tall it is, obviously. And then your style, right, which is fill, stroke, right, opacity, and stroke opacity. So this is exactly what I need, except I need to parameterize most of these things, right? So that's what I'm gonna do basically. So so overall width and height, let's just call this box width, and box H. Right. So rectangle X would be, let's say start X, and start Y. Right. Width, of course, W, and then H. I don't know why I didn't do just X and Y. Let's just do X and Y. Less typing in the replace section. So, and then of course we would need, what else do we need? So we need fill, right? So this is a color code here. So let's replace this with fill, stroke. Yeah, just I think stroke can. Yeah, let's do stroke color. Stroke color. Stroke width, it's not going to change on us, so I'm going to leave it hard coded. Again, feel free to parameterize it. I just don't need it for this particular example. Opacity, we do need that. So I'm going to call it OPP. And I'm going to use opacity for both stroke and fill. I'm going to use the same parameter because I don't differentiate them. Either everything is gone or everything is there. Again, you can parameterize them with separate parameters so that you can actually control them separately in your, by supplying this data in your legend. So now I need to create all the replace properties here, right, for it. So let's create some entries here and start putting in our placeholders. So box width, box height. All right, and I got one too many here, so we're gonna remove one. Okay, so we have all the parameters that our SVG would need. Let's look at the result. Make sure nothing slipped through, so no placeholders have slipped through, and that's good. Oh, box H slipped through, so that's because we have forgotten to mark it with these braces. Again, it's just personal convention, right? Typically, I delineate placeholders with this triangle braces here, just so it's kind of easy to pick them apart from the rest of the code. Personal preference, of course, and also this ensures that you don't accidentally replace the same set of characters somewhere else in your text where you don't need to, right? So this way, I ensure that by accident there won't be another occurrence of this that gets replaced that I'm not intending to, right? So okay, so that check one more time, right? So nothing is left out in here. Nope, all good. So now let's start populating things in there. So okay, starting timestamp X and Y. I would need to run them through scale, right? That scales from my using the timestamps and producing actual pixels, right? Because I need to go tell it the coordinates where to plot, but I have timestamps against which to plot. So let's calculate that. I'm gonna need what? I'm gonna need a scale block. Right, so this one is going to be calculating our start X position. So I'll just name it that so it's clear. Right, so starting position would have an input of our current timestamp. So basically this map to table, which is this here. So I'm going to let me close it so you don't get confused. I'm going to open it again as I need it. Right, so I'm going to open this current row, starting timestamp. That's my input. The range, of course, is overall start and end timestamp, right? So see, I did need this. Then the output would be between 0 and overall width of my whole bar, which is line W, right? Sorry, oops, wrong thing. Combined, yeah, so it's 0. And the width of the bar there. Right, so this gives me my starting position, which would go box, X here. Boom. By the way, the whole box width and height, right? We can populate that right away with line width and line height. Right. Now Y. So that's let's see. So for starting Y position, now normally you could say it's 0, right? If you wanted to plot like at the, like again, the bar that's going to match the width of this whole group, right? Which I don't want to do. So I'm going to need to do a little bit of math on the Y position here as well. So I'm going to write a very short script that simply looks at overall available height to it. And then basically, if it's smaller than my limit, I'm gonna use the whole height, right? So the bar, if you plug in a lot of series, you don't have a lot of vertical space, it will use all the space that it gets until it gets to a certain size, let's say 50 pixels, and it's gonna stop at that. So as your overall group becomes larger, the bar that you're drawing will remain at 50 pixels, right? So I'm gonna use kind of very simple script block. This one, I don't mind using script block for because the script for it will be very self-explanatory. So it's going to take an input of height, or it's going to be a number, right? And it's going to give you an output of bar y and bar h. So it's going to give you height and y position at which to start. Right. So I already, have a script basically already kind of typed out and saved. I'm just going to paste it. So in interest of time, right here, right? So let me quickly go over what I'm doing here. So the bar height, right, is going to be 80% of the available bar. Right? So the plotted bar, right, the bar that I'm going to draw will be 80% of your overall group in which I can draw, right? As long as it's less than 50 pixels. If that 80% becomes over 50 pixels, I'm just going to use 50 pixels, right? So it'll never go over 50 pixels. Again, notice I got a little bit lazy here. I don't parameterize this. I'll just hard code 50 pixels. Again, you can just pass that parameter into the script so that it's not hard coded, and have that configuration available for your widget. I'm skipping this because I'm lazy, or at least I'm not. I'm not trying to build a widget that serves every possible styling scenario, because otherwise we'll never get done. So there's that. And then bar. So once we know the height, right, it's going to be either 50 pixels or less. We can calculate the y position at which to start drawing the bar, which is basically kind of finding the center of the group and then stepping up half of the width of the bar, right? So finding the center, and then if bar is 50 pixels, going 25 pixels up from the center. That's where you start drawing the bar. That's your y position, right? So very, very simple. So I need to pass in the full height of the bar, which is h here. All right. So it gives me bar y and bar h. So that can go straight to the y. Okay. So next I need width and height. So let's see. So with height, it's easy because my script tells me that. So sorry, actually I mislabeled it. So bar y goes in here, and bar h goes in here, right? So that's my height. That's simple enough. Now the width, right? Yeah, that's the key, because that's gonna draw that segment of the bar that's exactly as wide as as it needs to be based on timestamps. So that needs to be calculated. So for that, we need to know, we need to know the end x coordinate. So this is a start x, remember, right? We need to know the end x and then calculate the difference between them, right? That's going to be our width. So I'm going to duplicate this. And this time everything else remains the same, but this time, let's rename this. And x. This is the end of our segment. The input will be that second row, right? Because the start of the next value is is basically the end of my current value. Start of this value will be the end of start of next value will be the end of my current value. So therefore, I need the next row, which is this one, next row's timestamp, right? And there you go. This is the end coordinate of my segment. So now I just need to know the difference between the end and the start. So subtract. All right, so and start, right? And that happens to be the width of my rectangle. That goes in here. And look, we've got all the math in here, all the geometry in here. We just need to now provide the fill, stroke, and opacity. For that, we have our legend table, right? So we just need to, what do we need to do, right? So we have this legend table, right? We just need to filter out one row that matches to our current value and grab all its parameters. So it's going to be a filter block, right? Where the input is the legend table, right? And of course, we'll need a replace block to generate our filter expression. So replace. All right, and the expression will be value equals to, and then placeholder for value. And then we're going to replace the placeholder with what? That's right, with our current row's value. Done. All right, so that goes in condition, which gives us a row of our legend that corresponds to our current value at hand. Now, you may complicate this logic a little bit to have a fallback. I don't have a fallback, right? I expect that my value will match something in my legend table, right? If it doesn't, there's no color or no opacity. Sorry. But you can complicate this a bit by creating a fallback value in your legend, and then doing this logic slightly differently so that if there happens to be no results in this expression, then you use the fallback values, right? So you plot something at least with some sort of a color and opacity. Again, I'm not doing that. So fill, right? That's a given. Stroke, I'm just going to use white. So stroke is going to be the same on all the segments, and then opacity will be 1. So I'm not using stroke color as part of my styling. I can use the same color as my fill for my stroke. No, I like the stroke to be outlined, so we'll keep it to that. So that basically, there's our SVG expression, right? That should plot it for us. So I think we're ready to go ahead and try it. Oh yeah, we probably should need to bind it first, right? So SVG expression goes to here. And then, let's bind the rest of these outputs so that we can, so like a label will be here. Value, I'm going to bind from the original data table. And calculated bar height, 50%. Again, I may need it if I choose to do something with a styling, with a like overlay bar or background bar that matches our plotted bar, something, right? So might come in handy later. Well, for you, because I'm not going to take this any further than this. So there. So that gives us a nice table, which now includes SVG code for every segment right here. So what I can do now, I can bind this table to the data of my SVG repeater. And then here, right, in the repeater itself, since I already have a full code, I don't even need to do, I don't even need to do the the kind of placeholders, the code with placeholders, I can just have a placeholder for the whole code. So placeholder, remember in the SVG repeater, placeholders are, you delineate them with square brackets. And then inside square brackets, you specify a column name from which to draw this value. And my column name is the whole SVG code, right? So that's my SVG item is nothing but a couple of square braces with a reference to the column that contains the whole SVG code. So if I did it right, oh, I did do it right. Look at that. So let's go ahead and apply this. And look at this. Right? So everything got plotted. Now this, of course, these are two booleans where we said false would have zero opacity. That's why you have these gaps. And then here in the live status, we of course use two different colors for two different statuses, and then zero opacity for the third status, hence acting as a gap. As a matter of fact, we can go in here and tweak with our styling just a bit. So let me pick just a color, let's say green like this. Sorry, I'm just using this to copy the hex and paste it into, let's say, heating. So instead of red, right, there you go, right? Or maybe instead of one of the booleans. Right? So you kind of see how this works. Okay, so there's only one thing missing from here. And what's missing is hover over, right? So data tip. When you mouse over, you want to be able to see the data tip, right? So even the zoom works, see? But we're missing the data tip, and we would typically want that. So at least it could tell us start and end of this segment and what the value is here. Again, you can build the actual legend based on this legend table. You can build a legend, kind of underneath your symbol if you choose to. I'm not going to do this in the video because it's not related to the specific problem at hand. That's just eye candy as far as I'm concerned. But data tip is kind of a must, and it also not very intuitive. So that I will do as part of this exercise. So let's get back in. Right, and let's work on the data tip. So building SVG, building a symbol to use as a data tip for SVG repeater is a little bit tricky. Here's why. So here's SVG repeater, and there's a data tip symbol that would normally go in here, and it does. But well, let's get to this point. You'll see why it's tricky. So let's go ahead and just create a symbol. So let's create a group. I'm going to do some basic styling before I make it a symbol. So we'll use like a balloon style and data tip. Some rounded corners, vertical layout. Let's say it's going to have a text. Let's give it some spacing around it. So this will be value, and this will be from TS. I'm only putting text in there so later we would know what we wanted to put in there. The word to, and then and TS. Oops, I meant to do and TS. So maybe let's embolden the value a bit, make it bigger, and add a bit of a gap between these two guys, and make these overall smaller. Enough, and then add a little like kind of balloon tail or whatever you call it, pointer. So I'm just going to use a regular triangle. So let me do, first of all, let me do horizontal flex center alignment so that my triangle is in the center. I'm gonna turn it upside down because right now it's pointing up. I'm gonna unclip this container so that this rectangle is kind of offset into negative space, and I'm going to constrain this at certain negative space so that I can make my balloon be auto, right? Yet my triangle to still stick out, something like this. Let's make sure. Okay, let's make sure I don't have any outline. So it looks something like this, right? Not too pretty, but I think it'll do. It'll do the trick. I'll just add a little white space for balance here on the bottom. Okay, so I'm going to go ahead and make this into a symbol, convert to symbol, SVG data tip, like this. And let's give it a few properties just for so I can show you what the problem of using this with SVG repeater. So we'll do the value here, and then we'll add the other properties later. So great, right? We have a symbol, so we can go in here and go to SVG repeater and populate this data tip symbol property like this, right? So great, right? It shows up. Whoa, yay, cool. But how do we get values in there? Well, so if you expand this, you do have properties, right? So you can populate these, but you can't edit, right? There's no access to edit symbol in context. It's one of the shortfalls of SVG repeater, and so how do you open it in context? Why do you want it to be in context? Well, because you would need access to this whole line of things like values, that drive this to access to the proper one. So if we for example, we have this thing driving here, so we have start and end timestamp, right? And the bar start and end. And by the way, look at this. We did end up needing this, which is cool. So we would need these two, right, to then format it into actual date and then display them, right? But how do we pass them, right? So we would sort of have to pre-create everything using fake values, right, with hope that's going to work out. So here's the trick that I like to use in those cases when you cannot access the symbol to edit in context. So I'm going to go in here, right? And it's going to be driven, of course, by this repeater output table, right? Because that's what drives the SVG repeater. So I'm going to use select rows to just grab one row from this table. Let's say row number 0, why not? Okay. Create a table, right? Bind this one row and hit save, which serializes this one row. So now I can take this table, I'm just going to cut it from here, and this can be deleted. I can completely get out of this, go to this symbol that I'm working on, go in there, right? So here, right, normally I would work with, map to table, right, which will give me access to that whole row, but I'm outside of context here, right? I'm not in the repeater, so I don't get a row. And I cannot open it in context because SVG does not let you open it in context. So I'm going to paste this table, right? This table, it gives me everything that symbol would normally get when it's in the repeater, right? So I can work with this table. Let's call it this row, right? So it's clear. So I'm going to work with this table to do everything I need to do with it as if this came from map to table. So which is what? So I would need a value. So, and not just a value, I want to display a label, right? So like a formatted version of the value. All right, so now I need start timestamp and end timestamp. I have both. I just need to format them. So do date format. And I'm going to start, using this. I think I don't know if this is going to matter or not. Probably not. So I'm going to use just time, right? So I'm going to use the good old American standard here. So hour, minute, let's say second, like this, right? So that's going to be our start. Right, and then same thing, it's going to be our end, but driven by the bar end. Going in here. Oops, wrong block. So I said this is only the word to. This is the actual end. Okay, so now that it's bound, right, just from this hard-coded table, basically, well, serialized table, right, now I can bind map to table to this serialized table. Now everything's going to disappear in this instance, right? This, right? So, but I'm going to save the symbol anyway. So I'm going to close everything because when it's rendered in the repeater, all of it should come back, right? So we'll see. So I'm going to apply the symbol. So now it's saved. I'm going to go in here. Right. So I'm going to bind. Again, I'm going to use this data tip because I didn't save the symbol, right? So I'm going to use this data tip as my data tip symbol in my SVG repeater. Right. I believe I need to bind at least one property from the original table so that map to table works. It may not be the case, but I do just in case. That's why I have this one property here, value. So I'm just going to use the value from the repeater table here. Right. And I'm going to, well, actually, it should work already, right? If it doesn't, so you see that it doesn't right now. So technically it should, but it doesn't. So I'm going to apply this. Right. Oh yeah, I need to enable, of course, the mouse, and we'll deal with it. So now it works, right? So it needs to re-render the SVG repeater to start working, but now it works. So there, right? Cool. So there's one problem left. Well, first of all, we can delete this guy from here. Now I had to enable mouse on my bars to be able to, so that my SVG repeater can detect mouse, so it can show me my data tip. The problem is I lost my zoom because my chart now doesn't detect the mouse because my repeater blocks it. So what do I do here? Well, what we're going to do is on the bars container, which is blocking my chart, I'm going to go to advanced properties and search for click through and enable that. Right? But that's not enough. I need to go into a symbol here, and on this symbol also enable a click through. Right? And now the areas that are not occupied by SVG repeater should pass the click through all the way to the bottom to the chart. Right? So when I'm over the repeater, right, it's fine. But when I'm not, right, the chart receives my mouse. Right? And remember when we were seeing kind of the original data tips from the series that we hid, right? Remember the series that we sort of made invisible, right, by turning off the line fill and stroke on the original chart. But as we moused across it, we still saw some original data tips kind of come up from the darkness of of invisibility. Well, that's no longer an issue. It's no longer an issue because we've changed the series tick marks here So nothing in the data that drives this ghost series, so to say, not a single value will match any of these tick marks. So basically, not a single data point will get generated on this original series, meaning that there'll never be any original data tips that may pop up when you mouse over like an empty spot where they normally would be. So no, you'll no longer have to worry about that. That problem has been taken care of by simply replacing the true false tick marks with the series name tick marks. And that's it, right? So you have a chart. All you have left. I mean, you can use it as is, of course. You can even widgetize it as is, or you can, of course, make it a symbol. So this will be status bar chart, right? And we need to get in there and add some symbol properties. Namely, let's add text area, which would be histories, and a date range. So let's set the default date range to be always, let's say, relative current, I don't know, 12 hours. And they are going to be bound, of course, to this multi-history block that is doing our lifting here. And that goes here. Okay. Notice I didn't pay a whole lot of attention to styling of the actual axes, and you can style them to whatever shape or form that you want. There. So just need to drop a few histories in there. One. Look at that. See how many you'd have to render? Right. Again, my things here, they switch every few seconds, so they generate a lot of history here. But you saw how long it took to, for this to show up. But Zoom works, right? And then so on, right? So let's change to a bit less data here. 1 hour, right? More manageable. Let's do comma. Let's add another one here. So on. Oh, by the way, right now this of course has hard-coded legend, which is here. I'm going to copy this. I'm going to go to symbol properties, create another table of data called legend. Right, get out of the symbol. Just paste this legend here so I don't lose what I typed in, don't have to retype. Pass it in as a property this time. Go in here, get my property, and just bind it to the legend. So now it's driven by the property that's coming from the outside here. Again, how you dress this up is up to you. How parameterized you want this to be is also up to you. I made the basic thing, right? So there you go. So as always, this page will be available to you for download in the video description. So you'll be able to tweak it to your heart's desire. Meanwhile, we're ready to move on to the part 2, where we build a weekly heat map chart. That one was cool as well. So let's jump to it. Hey, real quick, before we really move on from here, there's one bug in here that I was literally found as I was saving, and it has to do with sizing look. So the problem is with a symbol. So basically, when we created the symbol, that's the bar width here. Here, jump in here and edit. Yeah, that one. It had a fixed width, right? Now, when it's in the repeater and you double click to edit in context, it's always showing you the current width, right, as an actual number, not a percent based. But what we didn't, right, what I didn't realize is it was also created with an actual number, right? It was never 100%, so it was not taking up the whole available space to it. So as I started resizing my chart symbol, I noticed that the bars didn't resize with the chart because they were basically hard coded to a serialized width. So what I had to do is I had to get in the symbol just like I did now and enter 100% for the width, right? It immediately obviously makes them 100% of the current stage, which is fine. As soon as we accept, right? Now they get rendered to be 100% of the repeater container. So now they will follow, right, the size of your chart like this, right? Where before the chart would shrink, but the bars would sort of just get cut off, right? Because they were set to a fixed width rather than a percent based width, right? So they're just quick correction on this. If you were following along, you may have found the same issue that resizing your widget does not make your bars kind of remain correspondent to your timeline. So that's basically how you'd fix it. Just get into edit one of the bars like this and type in 100% in here and just apply, right? Save the symbol, and that will take care of that little issue for you. Okay, now we're really ready to move on. All right, so first things first, we're going to start by creating a container to contain our widget. This will do. And now we're going to jump in and start with getting data. So we need some history data to actually work with as we create the widget. It is always easier to have the data when you work on something like this. If you don't, I would suggest that it's worth your while to simulate history data to still do this with the data at hand. Trying to do this with empty tables would take much longer and it will be a lot more difficult to figure out and troubleshoot. So I do have this memory usage, disk usage. Let's do disk usage maybe, or actually let's do CPU because it changes a lot. So let's use CPU usage as our source. All right, so our widget will be showing you 1 day per row split into 24 hourly blocks. So that means we need to, let's say, get at least a week worth of data. So let's do maybe this week. Actually, let's do always 7 days. So we'll do relative. So we'll do current 7 days. And that should give us 7 days with the interval being 1 day. So we don't need to go more granular than that because that's what our individual box or interval will show. So we'll do 1 hour. And so that's what we have. And also the roll up, right? So we can basically use average, min, max. Let's do max. Actually, no, for CPU, we're not going to use max because CPU does vary a lot. So we'll just use the average. And I think that's it. So, we have this data that has basically hourly line items, 7 days worth of it. So let's move on. So now we need to add a few elements to this data so we can start grouping it the way we need to. And the way we need to group it, of course, is to have a table where each row is 1 day, and that row contains another table which contains 24 hours of that day. It may sound complicated, but it's really not. So let's set our input and let's see what we need to map. So really the only thing we're missing is some sort of a unique date identifier that could allow us to roll it up by a day, which we already have. We have the date. We just need to, uh, I guess, parse out the actual date out of it and leave time alone so that we have clear days. And then we probably should have um, a, a column where date is formatted in a way we want to display it. So let's do 2 columns. So we're going to take what we have so far and we're going to add 2 columns. All right, so the date would come from formatted timestamp. So timestamp is the column name. And the format would be ISO standard, date only. Right, no time. The display date would be same thing, except we are going to use slightly different format here. We're actually going to include the weekday name and then month and date. So it would look something like this. All right. All right. So next, we're going to take this resulting table and we're going to group it by that day so that we end up with a row per day, and inside that row we are going to nest the data that includes all the rows within that day, basically all the hours within that day. Right, so we're gonna do basically group by date, right? The date that we created, right? And we're just gonna carry over the display date, and we'll have to make sure to nest the data here. So it would look something like this, right? You see you have a single row for each of the days. Inside you have a table, right? And what got rolled into that table, right? That's your nested data. What got rolled into that table is all the data that will have the same day, right? So here we see that the 15th here is the date, right? So all these rows, so from 0 to 23, so it's obviously hourly, right? So 24 hours in total are part of the 15th of December, right? So that's what's inside each of those tables because we grouped it and we included the nested data into the group. So next, we need to, let's go ahead and add what we need to add to our group, which is the chart itself, like this. So we're going to drop something into this chart right away just so we can generate both axes. They are going to be category axes, both of them. And here we can use for the date, we can use anything really. For a category, we can use anything as well. Let's maybe display. So this would look like this. Okay, so we're okay with this vertical axis. We're not okay with horizontal, right? So horizontal needs to display our hours. Also, maybe we're not so okay with the vertical axis because even though the labels are correct, I think the more intuitive way will be to sort them so that the most recent day is on the bottom. Typically, when people look at matrices of this type of data, they would expect to find the latest information towards the bottom, not towards the top. But that, of course, is up to your specific requirements. But in my case, I will resort this. So I'm going to use a sort block to simply turn this table inside out, sorting on the row, doing descending. And I'm going to go to my vertical axes here, kind of drill down to the data provider, and I'm going to link the sorted version. right? So that basically flipped the axes, right? And now we need to deal with horizontal. So here we need hours. We uh, don't really have a good place to get them. So technically, each of those nested tables could have all 24 hours, but it's not guaranteed. If they're missing timestamps, it may have less than 24 hours. So we technically wouldn't know which one to pick to use as our template for the H axis. So instead, um, I'm going to create a template table. Right, so we'll call this hour. And here, so I'm going to take that maybe a little bit lazy way out. So I'm going to add 24 rows. So basically the last index will be 23, like this, right? And let me delete everything here. And rather than manually typing in the hour, and what I want is hour index, which will be exactly the same as a row, and then also displayable hour format, which is basically HH column MM format. So what I'm going to do is this. So here I'll make a copy of this, run it through column mapping. All right, and so I need column called hour, right? And it's going to be equals to row. So sorry, I don't need equals because it's not an expression. I'm just literally referencing existing column. And for the second one, let's call it time. And it's going to be derived from so we're going to format the row to include both digits. Right, so here it would look like this. All right, then we're going to convert this to string. And then we're going to add a literal value of column 00 to simulate the minutes, like this. So this will be our hourly display. And now I'm going to take the result to our table here and simply serialize it. Now I can delete this. And that saved me from having to manually type in 24 rows worth of data, or maybe generating this procedurally through a script or some other way, right? This is one of the many ways to populate this. I chose this one, and I'm okay with that. So that can now be used to drive the horizontal axes of the chart. So we're going to H axes, again, get to the data provider, do the binding. And for category field, of course, right, we're going to use time. And that's good. So now let me do just a few bits of styling on the actual axis lines, just so they're a little bit easier on the eyes. Right now they're pretty dismal. So let's just make sure nothing crosses into our plot area. So all the tick marks will be facing outward, and let me use slightly lighter font like this. And we'll do the same for vertical axes. Again, we'll use slightly lighter font. And again, all the markers, the tick marks will be facing outside, and it'll be smaller in general. And the line itself, single pixel is enough. Okay, so that's fine. Plot area, I do want to include both horizontal and vertical grid lines like this, but make them much less prominent by reducing their opacity to, let's say, 20%. What this will do is, if I have missing data in my SVG repeater, right, these grid lines will still outline the squares where segment would be if it was there, right? So maintaining the kind of the matrix look. So done with this. Now, of course, I need a container that would contain my SVG segments that I'm yet to create. So I'm going to add another group in here. And just like with the previous chart, I'm going to use charts plot area to grab X, Y, width, and height. And constrain this group in exactly same manner as the chart we've built in a previous part. All right, so it'll occupy the plot area. Exactly. Except I think I misplaced X and Y. To swap them back. And there we go. So you can see that it conformed to plot area precisely, which is what we're looking for. Now we can actually start building our inner symbol that's supposed to get rendered here. The idea is that we're going to have a symbol that's going to get repeated based on this table that has 7 days. And inside that symbol, we're going to have a SVG repeater generating the boxes, the squares, segments. So this, of course, would have to be vertical layout. And probably maybe with a 1 pixel gap. So let's go ahead and name it rows, because that's what it is. Let's add a group in there, which we going to make into a symbol. All right, so convert to symbol. Let's call this SVG row, like this. So now I can safely delete this from here, right? Because this is a repeater. So I'm going to bind my data source to the repeater, and it's going to be unsorted. The result of my group by, right? Because I did the sorting, so the chart renders them basically from bottom to top, but the repeater will already do that, having the latest row on the bottom. So I don't need to sort it for the repeater, and using SVG row as of course my symbol. So let's go ahead and jump into the symbol. All right. Sorry, lost my bearing there. There you go. Now, because of how I created that, look, initially I created with no size and no position. So the whole container is that little dot in the corner. We can easily fix that by simply enabling flex shrink flex grow and applying it. And then if we go back, now it's in the proper spot. So this is what we want, and we can start by creating symbol properties. All right, so I would imagine we would need to know the date. And probably definitely the actual table of intervals. That's what our hours table is. Then, well, value format probably would be useful. So we can control how value is shown in the data tip, right? We don't want to display like 10 decimal places. We want to actually show some nicely formatted value. So let's call it value format. And I'm going to go and give it initial value of, let's say 2 decimal points, so 2 precision points, and some units. I don't know, let's say percent. However, if I only want to display percent units next to a number rather than actually scaling number up to be percent, I need to do it in single quotes like this. Right? If I don't use quotes here, then it will not only use percent units next to the number, it will actually multiply the number by 100 because it's assuming that you're getting basically a fraction and you want to turn it into a percentage. So I only want to display the percent sign next to it, so I'm going to use in the percent sign in single quotes. And then let's add a section for some scaling information. And so let's call this tile settings. And we definitely need to be able to specify, first of all, the gradient. So that's going to be the fill. Let's call it gradient. And then minimum and maximum value that would correspond to that gradient. So two numbers, number and number, min max. And let's give them initial values of 0 and 100. And also I'm going to set the initial gradient. Let's do just kind of standard green, yellow, red. All right, and let's accept this and go and link up some of those properties. All right, so I'm going to go to the render and link hours right in here. The date will come from the repeater table. So that's going to be that. A value format I'm not going to touch. That's already specified by default. Gradient and min-max are also already set as 0 to 1, but I'm going to explicitly type them in just so we're not guessing what they are right now. And maybe also explicitly set the gradient. Why not? All right, so these will later come from a overall symbol properties, right? Because once I'm done with this chart, I'm going to make this whole thing a symbol, and that symbol will have properties which will get them passed into here. So for now, I'm okay with what I have here, and we can jump into the symbol again. And now we can drop SVG repeater inside the symbol like this. Okay, so first things first, let's go to the data flow, and we are going to need the size of this group, basically the size of this instance of the symbol, to calculate the width of each of the segments, right? To plot them on SVG repeater. So that's going to be done just like in the previous section with the previous chart. It's going to come from resize event. And for that to work, we need to enable resize event in advanced properties. Right? We're doing this on the group that contains the SVG repeater because SVG repeater itself will not have those properties. So these are only available on the group. So that gets us width and height, right, in pixels. So it doesn't matter how relative that size is. We'll always get its pixel equivalent, which is what we need for calculations. Next, we're going to need to map to table to get access to our row of data, which looks like this. And then we need the data itself, which is hidden away in this nested table, if you remember. So I'm going to bring out a table. I'm going to call it data. Oh, data is already used. It's a reserved word, so let's call this I don't know, value data. And just going to bind directly from here. And that's what we're looking at. Right? Timestamp value, both of the types of dates, and that's enough for us, right? So next thing, we're going to need to, we're going to need to build a data flow repeater which calculates our SVG expression code, which we're going to feed to the SVG repeater. So I'm just going to throw a replace block
Place into my data flow and make it a symbol right away. Right click, convert to symbol, call it SVG item. Right? And then drag out a repeater, which is going to be driven by, arrange things a little bit. So map to table, actually no, this, let's do this in here. That, and that's going to be driven by the data table. That can stay down below, no problem. We no longer need this. And for the repeater, we need to specify what we're repeating, and that's going to be this SVG item symbol that we've just created. And now we can go inside and start editing the symbol. And first things first, let's go ahead and start working on our properties that we need to pass into the symbol. So let's determine what the symbol would need to take as an input, and not just take as an input, also what would we need to be present in our final output table, right? So we want to have a property for every column that we want to have in the table that this repeater will produce. So gradient, we need the gradient, right? So we don't need it in the table, but we need to know this inside the symbol to get our final color. So that's a given. Right. Next, min, max, and then bar width and height. So min, max, of course, will be user setting that sets our range for the gradient color, and the bar width and height would be, of course, the space available to us to draw. So let's do 4 numbers in here. So min, max, bar W, bar H. Right? So that we need the value itself, of course. Can do without that. Value, all right. We need to know full current date, I think. Let's pass it in just in case. Right. We need to know all the intervals, just like in our visual symbol. And that's that table that we keep passing through deeper and deeper. And finally, SVG code. SVG code, of course, will be an output, but we need to have our output table, from this repeater should have a column with SVG code, which means SVG has to be present here as the property. So make it a text area so it's easier to read. We'll call this SVG code. This is something this symbol will output, right? It's going to be read-only property. Okay, so let's go ahead and accept that. And let's fill in some of those properties before we go back into that symbol and actually build logic to do any of this that we just talked about. So min, max, a lot of it will come from symbol properties, right? Of this symbol that we're editing, this visual single bar symbol. So tile settings, right? This is our min, max. No min, that's not good. 0 is our default min. So let's go ahead and do the bindings there. Right. Okay, so bar width and height, this is where our resize event comes into play. This is basically we're detecting width and height of the single bar here container and passing it in.
value will of course come from here somewhere. No, not from here. It'll actually come from the table itself. What am I thinking? So this is the table. Value will come from here because it's going to be different for every hour. So it's not a single value that will bind. It's a whole column of the table. Current date. Let's see. We can get current date from our map to table. Or wait, again, I think that again will need to come from here. So that's date corresponding to the hour that we're drawing here. Intervals, that's coming again from the one we've passed into this symbol. So just straight through, and that's it. And SVG code will be an output, right? So the output table, right, it contains, it's a table of all the properties that symbol has. That's what repeater outputs. So we have everything except for SVG code. And of course, SVG code is the main thing that we need. So now we need to work on creating that. So let's get back into the symbol. And now we have all the properties passed in and populated to start building logic to populate this one last property, SVG code. Okay, so we're going to start by, of course, dropping the map to table block, which will give us access to the whole row of the table that drives this repeater. This. Next, well, there will be a replace block here. That's how we're going to create our SVG item, which is going to have a bunch of stuff. Again, we're going to use exactly the same syntax from the SVG code required to draw a rectangle. It's almost the same as the one in the previous chart. So you can just copy it from there and modify it, which is what I did. So it's going to look something like this, right? So rectangle X, Y, width and height. All right. And then your fills. And I mean, it's exactly like SVG code from our previous chart widget. Where all the things are parameterized. So now we just need to, let's go ahead and apply this. Now we need to create all the proper line items there to replace our placeholders with actual values. So let's add some of them, right? So, and populate them in here. So X, Y, box W. Oh, not sure how the cap came on there. Box W. Box 8, box H, and then really we only need to care about, let's see, what do we, oh yeah, we need the actual width and height of the rectangle. So W, H, right, then I think the only thing we need is the fill, right? Because that's really it. So actually, I added too many there. So fill is the only other thing we need here. Everything else is more or less hard coded. So fill will basically be a color that corresponds, and that's that. So now we can start filling these in a bit. All right, and first we need to get a single color that corresponds to a particular point on the gradient based on min max and where the value falls in there, right? So there's a gradient mapping block that we're going to use for it. We've done this before in one of the lessons, so this shouldn't be too surprising to you. So min max, of course, will be defined min max. So make sure I have the proper property inspector here, there, just in case, because this might have been from like a previous session or something. Yeah, so min max, right, comes from our user defined min max. The input will be the value. It's gonna land somewhere in between there. If it doesn't, then your min max is not specified correctly. You can just change that. And then the gradient. So here the expectation is the gradient, not fill, but just the gradient, which means we can't really just do this, right? We can't do that. The reason we cannot is because this is not a gradient type property. This is a fill type property. When you click on it, you see that you have all different types of fill. Gradient is just one of them. So the way you bind just the gradient is, of course, go fill around for this outer blue dot. The inner one corresponds to individual color stop in the gradient here. This one corresponds to the whole gradient, right? And that's what we're going to bind. And that, of course, immediately yields us a color. Now, if you recall, in the lesson about zone viewer, right, we have wrote a bit of a script that does that translates basically RGBA value like this. That's what this gradient mapping gives you into the hex color code, which is what's needed for the SVG repeater. And we're basically ignoring the alpha here. This widget, we're not designing it to work with transparencies. You could do that if you really wanted to, but I could see problems there. So we're just not going to do that. So we need a string block, not sorry, a script block here that will right, that will receive basically a color in the form of a string, right, like this, and that will output a hex. So I went into that the zone viewer project, and I went ahead and copied the script from there. So I'm going to paste it here. Feel free to kind of pause and copy it from here and retype it from here if you really want to. Here's what it looks like. Or you can just go to the one of the prior projects and copy it from there. And again, this page will be available to you for download under the video. So you could just browse and find it here as well. All right. So this gives us the hex code, which we can use for the fill pretty much right away. That's the fill. Okay. Now we need to take care of all the geometry there. So box width and height, that's easy, right? That comes from box width and height available to us. That's already passed into this symbol like this round. Then we can safely say that our y here, the box y, will be 0, and we can also safely say that our segment height will be equal to the box height. So why is because the way we're designing this is our segments will always take the whole bar height, right? They'll be top to bottom. There won't be certain fixed size within the bar like we did for last chart. Here they're going to take up the full bar all the time, which means segment height will always equal to bar height, whole box height. And then y position, the drawing will always start at the very top, which is y equaling to 0. So we need to know x and we need to know w, right? So basically horizontal starting position and horizontal width. Well, width is always horizontal, I assume. So the width, we need to know the width. Let's first think of the x. So x would be, no, actually, let's do the width. It's the easiest one. So to know the width of the single segment, the element, since it's going to be equal for all 24 of them, we're splitting the day into 24 equal segments. We just need to take the overall width of the bar, which is this, and divide it by the number of intervals that we need to display, which technically is 24. So let's do divide. Yep, and try to spell it properly. All right, divide here. So we're going to take the bar width and The quick way to do this would be to just type in 24. The proper way to do this would be to measure the length of this intervals table and divide it by that. Um, so this chart becomes a bit more flexible and you can repurpose it easier. So like this. So and this will be the width of our segment. Now we need to know the x position. The x position would, of course, correspond to the width of each segment, so over a single segment, multiplied by how many segments have been built prior to this one, so prior to this index. So actually, to illustrate this better, right now I'm editing instance 0, so right, so my row here is 0. So instead of doing that, so let me accept the changes there, and I'm going to edit, let's say, instance 8, right, something non-zero. So if we look at map to table, right, so this corresponds to row 8, so which means, right, we're going to multiply this value, so width of the single segment, by the index of the item itself, right? So this basically this will be the total number of segments prior to this one, this particular instance that we're dealing with, that have already been rendered supposedly, and basically at this point in on your horizontal axes, you would need to start rendering this one, right? So that's going to be the x position. If I calculate this correctly, at the most we may need to subtract or add 1 from there, but I think we're okay because these start from 0. The very first segment will be 0, so it'll start at 0. Then the next segment will have 1 in here, so it'll start at 1 times whatever, 34 something, right? So it'll be 1 segment over, and on and on and on. So I think this is all that's needed, which would mean that we're done with SVG. So this is our final SVG in here. So we just need to change the stroke color to white here. I think, white outline is good enough. Oops, not here though. We need to go to the top and do this here. Again, feel free to parameterize that and just make it user adjustable. I'm not going to do that. So I'll just do hard-coded white. And then opacity, again, we're not playing with opacity at all here. Opacity will be just hard-coded 1 for both fill and stroke. So I think, as a matter of fact, let's do no stroke. Let's do 0. 0 for stroke. No, let's do 1 for stroke, but 0 opacity. So basically it would create like a 1 pixel space, but it won't be filled by anything. So there. So finally, so this final result then would be bound to this SVG code property. There. Okay. And so now our repeater output table contains everything we need, which is really just SVG code. Well, at least to draw it, right? We're going to need some of this other stuff for the data tip. But to draw it, this should be all we need, which would mean that if we go ahead and bind this data, sorry, not this data, yeah, this data, to the SVG repeater, and then for SVG item, right, we just reference that column that contains our SVG code, right? We get something like this. Look, this is starting to look like a proper bar. So let's go ahead and accept this. So all of them get rendered. Look, cool. Let's adjust our scale a little bit, because you can see that obviously there's not a lot of variance, so it looks pretty pretty identical. So let's set minimum, or I think maximum is too low, too high. So let's do maybe maximum 40. Looks like our CPU is not getting much of a workout here. That's why it's so different. 30. Yeah, now we're starting to get in the area there. Let's do this. Let's use memory. So let me go back to 100 here. Like, I think memory just has better data. CPU, fluctuates much faster, so it averages out to very similar numbers overall. So for memory, let's do 0 to 100. Let's go back to our history item here, and let's use this one instead. So I'm just gonna remove that and bring in this. There. So this actually has some recognizable patterns here. And I'm gonna change the scale a bit further to underline those patterns. Right. So 50 to 100, because that's where mostly my memory spends, because my little Raspberry Pi here that's running this is always working hard, because it has a bunch of links and a bunch of stuff running and testing. So, and you can tell from this right away is that around 9 o'clock, almost every other day, it resets, right? So it runs out of memory and blam, resets, and then on. And then every, I guess, wait, that's every odd day. Every even day, it happens to do that at like 1 a.m. and then again at 19, so 7 p.m. All right. So we just need to deal with, we need to deal with data tip to make this more than just pattern recognition exercise, but actually to be able to take a look at some of the data behind this. So let's get back into one of these line items. Hold on, let me do this. So I don't have to start from scratch. What I'm going to do is I'm going to open exercise, previous chart that we've done. Like I said, it will be available to you to download as well. And I'm going to just steal the data tip symbol from here. And we're going to go to symbols and paste it here like this, right? And I'm going to modify it to kind of fit this better. So I'm going to get back in here, and remember to work with a new data, a data row, since we cannot edit the in context, right? The data tip in context. We need to have a row of data, temporary data, to do our linking. And then, of course, we can switch back to map to table. For those who forgot what I'm talking about, this is what we've done in the previous chart in the first part of this video, but I'm going to remind you right now. So first, let's use this data tip here as our data tip for our SVG repeater, which now basically does this. It doesn't work out of the box because it's not geared for this particular instance, for this kind of data table. So let's go ahead and get here and get one row of this table. So select rows. All right, let's just get row 1. We're gonna basically serialize a table with that one row. Right, looks like this. Right, timestamp, value, and then two kinds of dates. So we're going to copy this. Now we can I did cut, right? So it copies and deletes it right away. So now we can go to edit our SVG data tip out of context, right? So which means this map to table would not work for us, but now we have a table to work for us, the one we copied. So we can temporarily do this, right? So now this guy has the data that we need. So we can do our, our dark dark magic there. So what we need to do there is this, right? So we have timestamp for current hour. Let's say we're looking at 12 o'clock here, right? So we have a timestamp for 12 o'clock. What we want to show that the square represents from 12 to 1 o'clock, right? Because we're looking at 1 hour that spans between 12 and 1 o'clock. So you would need to say from 12 p.m. to 1 p.m. and then the value that's formatted in a way that that's expected. So that means we first need to be able to pass in the format. So I'm going to edit symbol properties, and this has a value. I'm going to add one more section called format, right? And because I won't be able to edit the symbol in context anyway, right, to have this format populated, I'm going to type in a format here, and it's going to act as a default, as a fallback, right? So if format is not specified, it's going to use what's serialized with the symbol, which is what I'm typing in. So whatever you type in while editing the symbol into symbol properties gets serialized with a symbol and gets used as a default value if null is being passed from the outside, right? So basically, if you don't pass anything from the outside. So again, we can use this formatting we used for the percentage. All right, and let's first populate the value. So this is where value used to be, right? Now we are going to use format number. Oops. So number will be this, format will be this, and the output will be going to the thing, right? Of course, not going to see anything because we're out of context, don't have a value in here, don't care, don't need it. Now for the from section, right? So for the from, we do have in this table, already opened it. So we have this Tuesday, December 15th, right? Great. That's going to work for us as from date. It doesn't have the time. We want the time. So no, it's not going to work for us. We need to format our own from. So let's use date format. Right, it's going to be this full timestamp. Right, and let's do auto, meaning that it's not going to try to attempt to convert this to a local timestamp. So it's going to just use whatever it has. So we want to display first hour. So let's do something like this. H mm. All right, so like this, 1 a.m. And the date is already in axis, so we don't need a date. This is fine. Okay. So this, we're going to display this in from. Actually, let's use the full date so that you don't have to glance over to the axis to understand what day you're looking at. Right, like this, December 15th. And then we need one more timestamp that's 1 hour later from compared to this one. So we have a date math block here that can take care of that for us. Right, so we're gonna start with the same timestamp. All right, and we're gonna do after and then do 1 hour. So add 1 hour, and then we're gonna use same exact format block on the result of this date math block, right? Which gives us exactly 1 hour later after the timestamp. So that's of course is going to be our end timestamp like this. So let's go ahead and apply this. And there, right? This is what we got. So what we need to do there then is bind the value and bind the format. So value, of course, will come from the table that drives the repeater. Right, and the format format is passed directly from the symbol properties that we're passing into this symbol in the first place. So from here. All right. So now, all right, we're done with this. If you want to introduce a little bit of vertical separation to match the horizontal separation, right, we can add 1 pixel of vertical separation and done. So, and we have a timestamp, we have formatting here, we have hours in the bottom. So we have a full heat map of basically what happened. And oops, I shouldn't have touched that because just Control Z. Oh, that's not what I wanted to undo. Sorry, I wasn't supposed to touch the sizing there. This is what I want to resize. There. So now we can just convert this to a symbol, and then create symbol properties that would that would ask user to provide the path of the history that he would want to display here, and maybe the certain basic things like number formatting that he wants to pass in. Basically, whatever you want, whatever settings you want to pass into this to this render. All right, scale, of course, scale, gradient, and then value format. All right, I'm not going to convert this to a symbol so that it's easier for you to pick apart when you download it. No, actually, I will, because then you might choose to just use it as is. So I am going to go ahead and convert this to a symbol. We'll call it heat map chart. All right, and I'm going to edit the symbol and go to my properties and create symbol parameters. Let's say history path. All right. Call it gradient. All right. Let's go with min. Max. And let's put this in the section called scale. And this as well. All right. And what else do we? Oh yeah, number format. Let's do value format. All right. And again, we'll type in the default. Okay, so let's set these defaults as well. Let's set gradient to be actual gradient. Again, let's use from white to blue. It's a different blue here. And then we can bind these to the places that actually expect them. So gradient, this is fill, so it gets bound directly to fill. Then format to format. Min max. And then finally, let's not forget that we need to bind the history path to history path. Right, and let's add a trigger to refresh this. So that you can re-request history as needed there. Oh, very important, date range. So let's use a date range property. Set the default to, let's say, current 7 days, just like we had before. Okay, now we're good. So now we just need to give this a history path. So let's go find one of our histories. Let's try a different one. Let's try a disk usage now. So I'm going to hold and drop it with the control. So here we go. All right. And we get something like this, which means I'm barely using any of my drive space. So I would need to, I'll seriously need to adjust the scale here. Let's say 0 to 10 maybe. No, nothing falls in there, huh? 0 to 90, 40, 20. I don't know. There are probably a few peaks that really throw this off, and then the rest is, I guess, not the best history. So let's try a different temp. It's temp. I can't remember. Oh yeah, temp. I don't think has enough history, but I did set it up to follow the outside temperature here in sunny but cold California at the moment. So yeah, this is actually, this is not a percent. So let's not show percent. This is degrees Fahrenheit there. So this shows you actually the temperature variance through the day. You see, it never really got too hot, but it was a good 57. So not too bad. So I only did this 3 days ago, so you only see 3 days worth of stuff. But this is a much better representative of data. So there you go. It's basically ready for you to use or dissect and build your own. So with that, let's get back to the studio. Enjoy.
Hey, welcome back. So hopefully this gives you 2 more great tools to tune your project just perfect per requirements from your customers. And remember, if you're ever in a bind, DG professional services are always available to you to engage at any level, from turnkey projects to partial engagement, like building specific widgets or components, or simply support. So feel free to reach out to us if you need any help. With that said, I'm Paul Sinenko, and go build something.